Hello children, today I am here to do revision exercise 1. So we covered 9 chapters in the first term. So you have to do all exercises and examples in first 9 chapters and then try the revision exercise 1. So we'll do this. Question number 1. Simplify the following. So just addition. So what you can do, addition, the order is not important. So you can add these two first and then the other number. 8, 2 plus 12. You can add it together. 8 plus 2, 10. 1 remaining. 3, 4. So 40 is the answer. Question number 2. Subtraction is also, there's no order. So you can start from left. 18 minus 12, you get 6. Then add 6 to that, you get 12 there. This one, addition and subtraction, there's no order. 9 plus 6, 15. 15 minus 8, you get 7. Now multiplication. There you need to first do multiplication before subtraction. 8 times 7, 56 minus 12, you get 4 here and 4. 56 minus 12, you get 44. Multiplication and addition. So multiplication first. 7 times 3, 21. 21 plus 5, 26. This one, division is there. So you have to do division first. So 24 minus 18 divided by 3, that's 6. So subtract, you get 8 and 1, 18. This one, division first. So when you do division, you get 15 plus 18 divided by 3, you get 6. 15 plus 6, 21. This one, multiplication first. 5 times 3, 15. 16 plus 15, answer is 31. What about this one? Division first. 15 minus 9 divided by 3 is 3. 15 minus 3, you get 12. This one, Jacinta says when we simplify 91 minus 35 divided by 7, we get 8 as the answer. Explain why Jacinta's answer is incorrect. So this is subtraction and division. You have to do division first. 91 minus 35 divided by 7, you get 5. 91 minus 5, you get 86. The answer is 86, but Jacinta got 8. So what do you think the operation he did? I think he forgot to do division first. We'll see. Maybe he did subtraction first. 91 minus 35. 56 divided by 7, that's 8. So this is wrong. So you have to do division first. So you can write Jacinta's answer is incorrect. Why? Needs to do division first. Needs to do division first. Look at this one. What is a bilaterally symmetric plane figure? So if a plane figure divided by the straight line into two identical parts, we call that's a bilateral symmetric plane. So we can write down, if a line can divide the plane figure into two identical parts. The plane figure is bilaterally symmetric. Bilaterally symmetric. So that means left hand side overlaps. When you fold it along the line, it exactly overlaps with the other one without any extra parts. Then write the number of axes of symmetry in each of the following symmetric figures given below. Here you can divide this one into these two parts, and also you can divide here into this part. So you get two axes of symmetry. This is an isosceles triangle. So you can draw only one line. So one axis of symmetry. What about this one? This one, you can draw a line here and also here. So two. This one, you can draw a line this way, and these two are the same, so you can divide here as well. So two axes of symmetry. Draw the following symmetric figures in your square rule exercise book. Draw the axis of symmetry and name them. A rectilinear plane figure with only one axis of symmetry. So one axis of symmetry. So we'll draw a figure with one axis of symmetry. Something like this. So you get one line, one axis of symmetry. This is the axis of symmetry. You get one line. Then a rectilinear plane figure with only two axes of symmetry. So two axes of symmetry means we can just draw the axis of symmetry this way and then complete the figure. So we'll draw something like this way. So you need to get same part on this other side, like this. See? So you get two parts, same part in all four sections. And third one, a rectilinear plane figure with more than two axes of symmetry. You know that a square has four. So I'll draw first the four lines. 1, 2, and I'll take this line and 3 down and draw this line 1, 2, 3, 4. 4 lines. Now I can complete the diagram. So I'll draw 1. I'll draw the square now. 1, 2, 3, 1, 2, 3 here. 1, 2, 3, 1, 2, 3. So all sides are equal. A square. So more than 2 axes of symmetry. Look at this question. If the plane figure is cut along the dotted line, then it will be divided into 2 parts which coincide with each other. Is the figure bilaterally symmetric about this line? So when you fold it, you need to get the same shape here when you fold it along this line. But we can't get, this is not same as 3 centimeters. So if we rotate, and you can keep it into overlaps with the other one, but not with this line. When you fold it, you are not getting the same part. Is the figure bilaterally symmetric about this line? No. Explain your answer giving reasons. When you fold it, along the dotted line, two parts do not fit each other. That's called not bilaterally symmetry. If you get the same shape when you fold it, it's bilaterally symmetric. When you fold along the dotted line, 2 parts do not fit each other. So that's not bilaterally symmetric figure. Copy each of the following figures onto your square ruled paper and complete each figure such that the 2 dotted lines becomes axis of symmetry of the completed figure. So 2 axes of symmetry, so you have to complete this diagram. So think about how many squares this way, 3. So you have to mark 3 squares here, 3 squares to this side, 1, 2, 3 here. Now connect. Here to here, and here to here, here to here. So this is the figure you get when you complete the diagram. This one like a staircase. So how you complete it? So you draw a line here, here. One goes up, and so this is like a staircase. Now going down. Now going down. Now going down. 1 square to the right, 1 square down. And here 2 squares. And then continue this one down. So you get something like this when you complete it. So you get 2 axes of symmetry to this figure. Set A is given below by listing its elements. 2, 3, 5, 7. Write A using a common property of its element. Descriptive way. How can we write down descriptive way? 2, 3, 5, 7 are prime numbers. So you can write A prime numbers less than 10. Second one, rewrite P by listing its elements. So P is given factors of 12. So what are the factors? 1 is a factor. 2, you can divide by 2. You can divide by 3. You can divide by 4. You can divide by 6 and again by 12. So those are the factors of 12. A is multiples of 3 that lie between 8 and 20. Write A by listing its elements. How can we write A? Multiples of 3 that lie between 8 and 20. So 3, 6 you can't take. 9, 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 21 you can't. So that's 9, 12, 15, 18. Represent A in a Venn diagram. This is part A, part B. So you can draw a closed figure like this and put all the elements inside the circle. So that's set A. Fourth one, write the set represented by the Venn diagram. This is given using a common property of its elements. Descriptive way. How we write down 9, 18. 27, 36, 45. Those are multiples of 9. So you can write A is a set of multiples of 9. You can write up to 45 or less than 50. Can we write less than 50? Yeah. So less than 50 also okay. 9 times 6, 54. 9 times 5, 45. So multiples of 9 less than 50. By listing its elements, so you can write A is the set. And you can write all the elements there. 9, 18, 27, 36, 45. When you are writing elements, a comma in between and you can't repeat the same number twice. Write the factors of 44. Factors of 44. How do you find out the factors? You can divide and see. You can divide by 1. You can divide by 2. So if you can't figure it out at once, you can see by dividing this one up till you get 1. 2 times 22, 11, 11 times 1. Now here we see 4 times also, okay, 4 times 11. And what else? 11 is there. And 11 times 2, 22. And finally, 44. So those are the factors of 44. Write the prime factors of 44. So what are the prime numbers there? Prime factors of 44. Only 2. 2 is a prime number. Third one. Find the highest common factor of the third one. Write 56 as a product of its prime factors. 56. Divide and see. Divide by 2. 28. Divide by 2 again. 40. Divide by 2. 7. And divide by 7. You get 1. So you can write 56 as product of prime factors. 2 times 2 times 2 times 7, or you can write 2 to the power 3 into 7 to the power 1. So product of its prime factors. Now we'll do the fourth part, the next page. Find the highest common factor of 18, 30 and 42. So we'll write down separately 18, 30, 42, because fifth part you want least common multiple. So we'll write down the factors separately and find out both at once. What are the factors of 18? 2 and 9, divide by 3, you get 1. 2 times 3 times 3. Factors of 30. 15, divide by 3 and 5. 2, 3, 5. 42, divide by 2, divide by 3. 2, 3, 7. Now to get the highest common factor, you find out all the common factors. 2 is common, 3 is common. So what's the highest common factor? 2 times 3, that's 6. Now we'll find out the lowest common multiple. So lowest common multiple, what you do? You take different numbers with highest power. Power 1 here, power 1 for 2. So lowest common multiple, this is 2. This one, you get 3 to the power 2. 2 and 3 to the power 2 here. 2, 3, 5. And here 2, 3, 7. 3 to the power 2 is the maximum power. So you take 3 squared. And 5 is there, 7 is there. 3 squared is 9. 9 times 5, 45. 45 times 2, 90. 90 times 7, 60. 3 and 0, 630. So lowest common multiple is 630. What is the digital root of 522? How we find out the digital root? You add the digits. 5 plus 2 plus 2. 9. So digital root is 9. Using the digital root, explain why 522 is divisible by 3. The digital root is either 3, 6, 9. The number is divisible by 3. Divisible by 3 without a remainder. So 9 is there. Therefore, 522 is divisible by 3. Third part. Using the digital root, explain why 522 is divisible by 9. Because digital root is 9. Therefore, it is divisible by 9. How do we find out without dividing a number whether it is divisible by 4 or not? You check the last 2 digits. If last 2 digits is divisible by 4, then the number is divisible by or last two digits 0 is also the number divisible by 4. Last two digits 0 also divisible by 3. I'll write it here. So either last two digits 0 or the last two digits divisible by 4. This one, 4321, are 4 numbers written on 4 cards. How many numbers which are divisible by 4 can be made using all these cards? Write down all such numbers. So what's the condition? Last two digits should be divisible by 4. 43 can't, 42 can't, 41. So other way around, 24 possible. Last two digits. Then what are the other numbers? 34 can't, 32 also possible. Last two digits either 24 or 32. So then other two numbers can be any order. If you take 2, 4, you get 1, 3, or so either this or I can write 3, 1 also. 3, 1 with 24. Those are the two possibilities with 24. With 32, what are the possibilities? 3, 2 there, that means 1, 4. 1, 4 or 4, 1. 32 should be there as the last two digits. So 4 possibilities are there. If the number 53 and a blank there which has 3 digits is divisible by 9, then what is the digit in the units place? So the digital root should be 9. 5 plus 3, you get 8. You need another 1. So what's the number? 5, 3, and this should be 1. And can we put another digit? Can we get the digital root 9 with a bigger number? 5, 3, 8. 8 and 9? 8 and 9, 17. So again you are getting digital root 8. So that's the maximum number again you are getting. So that's not possible. So 5, 3, 1. If the number 5, 3 space which has 3 digits is divisible by 6, then what is the digit in the units place? Divisible by 6 means this should be an even number. 2, 4 like that, and the digital root should be either 3, 6 or 9. So 8 is there already. So digital root, you need either 3, 6 or 9. So you can't put 1 there. That's an odd number. Then when you put 4 more, so what you get? 8 plus 4, you get 12. That means digital root again 3. So that's possible. So 4 is possible. So you can put 5, 3, 4. It's an even number as well as digital root. 8 plus 4, 12. 2 plus 1, 3. That's possible. Then how you get 6? You need to add. This is adding 4, adding 6. Adding 6, what you get? 14. So that's not possible. Adding 7. Adding 7, you get digital root 15. That's 6. But what's the problem? You can't put 7. That's an odd number. So that's also not possible. What else? To get 9 you can't get digital root 6. So only possibility is 5, 3, 4. Find the value of 6 squared. That means 6 times 6. You get 36. Write all the factors of the number corresponding to the value found in 1. So what are the factors of 36? Factors of 36. 1. You can divide by 2. You can divide by 3. 3 times 12. You can divide by 4 and 6. 9. So what else? 2 times, so 3. When you divide by 3, you get 12. When you divide by 4, that's 9. Divide by 2, get 18. And then 36. So those are the factors of 36. There are only 2 prime factors among the factors written in 2. Write down 3 more numbers where each of them has only 2 prime factors. So here 2 and 3 prime factors are there. So write another 3 more numbers. So we can do something like this. So 2 and 3 should be a prime factor. So 2 times 3, 6. So 6 with, you can take 6 times 2, 12. So 12 also possible. Then 2 times 3, 6. 6 times 3, 18. Then 6 times 3, 18. 18 times 2 or 18 times 3 also possible. 18 times 3, 64. So all these numbers you get factors. The prime factors 2 and 3. So we'll figure it out. 2. 2 times 2, 4. 4 times 3. So prime factors 2 and 3. And here you can multiply by this one 2, 9. 9 means 3 times 3. So prime factors 2 and 3. This one 2. Can you get 64? That's wrong. 18 times 3. 54. That's a mistake. So 64 only prime factors. 2 is there. So this should be 54. So what are the prime factors? 2. Then 2 times, divide by 2. You get 27. 27 means 3 times. 3 times 3. So 2 and 3 are the prime factors. Question number 7. Write whether the following statements are true or false. Any multiple of 2 has only one prime factor. Multiple of 2 means 2 times 2, 4. 2 times 3, 6. So 6. You can't say only one prime factor is there. That's false. Because 6 you get 2 and 3. Any number which can be written as the power of 2, 2, 4, 8 has 2 as its only prime factor. That's true. 2 to the power something you get. So prime factor is only 2. That's correct. True. Any multiple of 3 has only one prime factor. 3 times 2, 6. So 6 got 2 and 3. That's wrong. False. Any number which can be written as a power of 3 has only one prime factor. Yeah, that's 3. So that's true. Power of 3 means 3 is the prime factor. Any number which can be written as a power of 5 has 5 as its only prime factor. That's also true. The highest common factor of any two positive integers is less than or equal to their least common multiple. What do you think? Highest common factor of any two positive integers is less than or equal to their least common multiple. Always less or equal also possible. That's true. The highest common factor of any two distinct prime numbers is 1. If the two distinct prime numbers, highest common factor of any two distinct prime numbers, the highest common factor is 1. That's true. The highest common factor of 12 and 13 is 1. So there's a prime number. So 13 into 1. Here also 1 into 12. So 1 is the highest common factor. That's true. Question number 8. Explain giving reasons whether AD 1892 is a leap year or not. How we find out whether it's a leap year? 1892. We look at the last two digits. If it's divisible by 4, it's a leap year. 4 times 2, 8. For 12, that's 3. So divisible by 4, last two digits only, last two digits, so it's a leap year. Two, explain giving reasons whether 2100 is a leap year or not. 2100. If it's 0 as the last two digits, then you look at the next number, 21. 21 is not divisible by 4. So 21 is not divisible by 4. So therefore, not a leap year. Then third one. To which decade does the year 2100 belong to? That means every 10 years we call a decade. So what do? You cross out one digit, last digit, and if it's 0, we are not adding 1. So 210th decade. Add the following years, months and days. So what's the maximum days we can keep? 30. That's the standard. Months 12 and years you can find out. Add these two. You get 39. 39 can we keep? No. So 39 minus 30. So you write 9 here. Then this one, you get 1 here. 8 plus 6, 14. 14 plus 1, 15. 15 you can't keep. Subtract 12. So you get 3 months. And here, take 1 here. 4 plus 2, 6. 6 years, 3 months and 9 days. This one, 21 plus 9, 30. 30 means you can take as 1 month. 9 plus 1, that's 10. 10 plus 3, 13. 13 minus 12, that's 1. So you can take 1 here. 7 and 7, 14. So you get 24 there. Subtract the following. When you subtract these two, can you subtract 20 from 12? You can't. So you are taking 1 from month. That means 30 days. 30 plus 12, 42. 42 minus 20, you can subtract. That's 22. What about this one then? This one becomes 7. 7 minus 5, 2. 6 minus 4, 2. What about this one? You can't subtract. Take 30 from here. 30 plus 19, 49. Then subtract 25. You get 24. This becomes 6. So you can't subtract 9 from 6. You take 1 year. 12 plus 6, 18. 18 minus 9, 9 now. So this is 4. 4 minus 2, 2. The 5th birthday of a child fell on 2002, 8/26. His mass was 20 kilos and 700 grams on that day. When was his birthday? 5th birthday is this. So subtract 5. 2002 minus 8/26. Subtract 5. 26. 8. It's not changing. So you get 7. 9 and 19. 1997, 8/26 is the birthday. On his 8th birthday, his mass was 30 kilos, 600 grams. What is the increase in his mass during the 3 years? So you have to subtract the weights. So this is kilos and grams. So 8th birthday, 30 kilos and 600 grams. And 5th birthday, 20 kilos and 700 grams. So when you subtract, what you get? You can't subtract 700 from 600. So you have to take 1 kilo. 1 kilo means 1000 grams. 1600 minus 700. What you get? 900 grams there. So this becomes 29 minus 20. That's 9. 9 kilos and 900 grams increased. Third part, what was his age? What was his age on 2012, 3/25? Now we'll check with the birthday. So you take year, month, day. So here 2012, 3/25. And birthday 1997, 8/26. Now we'll subtract and find out his age. Can't subtract. Here, take 1 month. That means 30. 30 plus 25, 55. 55 minus 26, that's 29. This becomes 2 now. You can't subtract 8 from that. So take 1 year, that means 12 months. 12 plus 2, 14. 14 minus 8, that's 6 months. Then what happens here? This becomes 2011. 2011 minus 1997. You get 4 here and 1. So 14 years, 6 months and 29 days. 14 years, 6 months and 29 days. Last part. On 2012-325, the mass of the child was 12 kilos and 800 grams, more than his mass on his 5th birthday. Find the mass of the child on 2012-325. So that means you have to add 12 kilos and 800 to the initial mass given, 20. On his 5th birthday, it was 20 kilos and 700 grams. So we'll add it together. So we'll take 4th part here. 20 kilos and 700 grams was there. And then increased 12 kilos and 800 grams. Add together. Here you get 1500. So subtract 1000, you get 500 here. You are taking 1 to this side. So you get 3 and 3. So 33 kilos and 500 grams. Find the mass of child on this date. 33 kilos and 500 grams. Question number 11. Using the number line, determine each of the following sums. -6 and -4 addition. So we need, let's start from -10 here and say -10 minus 9. 8 minus 7, 6, 5, 4, 3, 2, 1, 1, 2. So here starting from 0, -6 means here. To the left by 6 squares. And -4, adding -4. From here another 4. Same direction. So now this is the final position. This is the initial position. So what's the total value? -10. So -6 and -5, you get -10. Second one, -5 and +5. So we'll use -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. This way. -5 means starting from 0, this side towards this side, -5. +5 means you are adding 5. So you move 5 places to the right from here. So what's the answer? You get 0. Look at the third part, +8 and -1. So we'll take minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So plus 8, that means 0 to plus 8, it means 8 squares to the right, this way. And from there, minus 9, 9 to the left. So what you get? 9 to the left. Final answer is minus 1. So plus 8 and minus 9 addition is minus 1. Simplify. Now without number line you can do. When the two numbers are with different signs, what you do? Take the difference. 10 and 4, difference is 6. And the larger number is negative, so you get negative 6. 9 and 5, two different signs. Take the difference. 4. Larger number is minus 4. This one both negative. So both negative or both positive, you add it. 8 plus 5, 13. And the sign is negative because both are negative. Positive. Add 1/4 and 1/4, you get 2/4. When you simplify, you get half. So this is plus. Sign is plus. Minus minus addition. Both signs are the same. You can add it. 5/7 and both minus. So this is also minus. This one is negative, one is plus. So take the difference. Take the difference and put the sign of the bigger number. 1.40. That's negative because negative 1.76 is the larger number. Look at question number 12. Complete the table given below by considering a person whose journey starts at A and ends at F. Two roads traveled, A to C through B, here to here. Name the angle between the two roads A, B, C. Name the vertex and the arms of the angle between the two roads. Vertex is B. What are the two arms? AB and BC. Name the type of angle between the two roads when classified according to its magnitude. This is 90 degrees. 90 degrees means right angle. B to D through C. Here. This is also we can see 90. So what's the angle? BCD. What's the vertex? C is the vertex. Arms are BC and CD. And that's also right angle. C to E through D. So you can see this is the angle now. CDE. What's the vertex? Vertex D, arms CD and DE. And this is more than 90, less than 180. Obtuse angle. D to F through E. E angle, this angle. D, E, F angle. So what's the vertex? E is the vertex and what are the arms? DE and EF. And this is a small angle, less than 90. Acute angle. Measure the magnitude of each angle given below using a protractor and write it down. So you need a protractor for that. So measure the angle. So you keep 0 point initial value on the vertex and measure the angle. So this is 45 degrees. So 45 degrees is the angle. What about this one? This one here to here, 120 degrees. It's an obtuse angle. And how we measure this one? Reflex angle. You measure the obtuse angle and subtract from 360. Obtuse angle is 110. This angle is 110. So how you find out the reflex angle? 360 minus 110. 250 degrees. So this angle, reflex angle, is 250 degrees. Draw the following angles using the protractor and the ruler. You need the ruler and the protractor. Okay, so how you draw an angle? First you have to draw a line. Then you need to mark a point. We'll draw it here, this point. Keep the protractor on top of that point with 0 and measure 65 degrees from here, and you can mark it. And then what you do? You take the ruler and keep here to this edge, and then we can rotate and draw the line. Here, now passes through this one. Now you can draw the line. Draw the line here. So you get, what's the value? 65 degree here. That's ABC. So B is the point. You can mark A, B, C. PQR 130. So again, take the you can take the ruler. We'll draw it somewhere here. Draw a line. Now you have to measure the angle. We'll take this point. Keep the protractor on top of that point. Measure 130. From here, 130 is here. Now you can take the ruler and connect it. Keep the ruler here, and we can rotate and get the other point here. Here, then you can draw the line. So that's 130 degrees. This angle. So Q is the vertex and R is the other point. PQR is 130 degrees. MNR is 145. So you need 145 now. Draw a line. And then we need to measure. We'll take a point first here. Measure 145 degrees. 145 is here. Now we can take the ruler and rotate so that you can draw the line. So you take the ruler and draw the line. This is 145 degrees. What's the angle? M in R. So 145. Two parallel lines are shown below. How far apart are they? So how we find out? We need the perpendicular distance. So for that you can take the ruler and keep on this parallel line, and then take the set square and you can keep this edge. This way we can keep on top of this line, on top of the ruler, and draw a line there. So that's the perpendicular, this and this 90 degrees perpendicular distance you are getting. So you draw the line, you get the perpendicular distance here to here. Now you can measure it and see. Here to here. We'll take the ruler and measure. Starting from here. What's the value? 4.7 centimeters. You get a different answer because my one enlarged, so my ruler is different, so you get a different answer. Draw a straight line segment and name it XY. XY. That's a straight line segment. Part B, mark a point A which is a distance of 4.8 centimeter from XY. So the perpendicular distance we need to take. So for that we can take the set square. So we'll keep the set square on top of the line. You need to keep it properly. Then what you do? You can mark from here 4.8 centimeters. 4.8 centimeters. Here 4.8 is somewhere here. From here 4.8 centimeters. And mark a point A. So I can mark A here. Draw a straight line segment through the point A parallel to XY. So what you can do, first I'll draw the line so that it's easy to I'll draw a broken line from here to here. That's the perpendicular distance. Now I can move the set square along this line. So this is point A. So I can draw a line, or I can do this way. So because I can't draw a full line, I can rotate this here, and I can put it here. I'll keep it like this and draw the line. So take the set square with the same angle. When you take it, you get same 90 degree. Then you can draw the line. Draw the line along point A. So that line and this line both are parallel. And the line distance is 4.8 centimeters. So this is the point A, and parallel to XY, this is the straight line. Draw the parallelogram ABCD. Draw parallel lines to diagonal AC through B and D. So we need to draw this parallelogram. So what we can do, we can first draw a straight line. And we can measure this length from here. So you get 6.6. So you can mark it here. 6.6. So I'll mark from here to here, 6.6. Then I need to draw this line. And if you want to draw the same parallelogram, you have to measure the angle. So this is 70 degrees. So from here, you can measure 70 degrees and mark the line here. Then you can now measure this length. First we'll draw the line. We'll draw the line first. Passes through these 2 points. We'll draw the line. So this is the line. Now we can measure this length. That's 5.8. So 5.8 you can draw from here. 5.8 somewhere here. Now what we do? We can draw the parallel lines. For that you can take the set square. So we can rotate this. Keep on top of this line. And what you can do, you can lift this one so that you get the same angle and you can draw this line. But this is not enough, so I'll take the other way around. So I'll take this way so that I can draw a big line. This line, so lift this up and you can draw the other line that's parallel. Now you have the two parallel lines. Now you have to take the same distance here. So 5.8 before, so you take, or you can measure this length. So what was the length we got before? 6.7. So you mark 6.7 from here. This is this point, 6.7. Now we have all 4 points, A, B, C, D. So you can connect B point with the C point. So this is the ABCD parallelogram. Now what we do? Draw parallel lines to diagonal AC through B and D. So we need diagonal AC. So first connect the diagonal A and C. Now we need to draw two parallel lines. For that we can take the ruler and the set square. So what we can do, you can keep the ruler on top of the AC line first. So like this. And then you can keep the set square on top of that. So keep the set square on top of that. And then you drag it so that you get the same parallel line. So you can drag it and now you draw the line. This line is a line parallel to AC. So again you take the set square, keep on top of this one with the same way. You don't need to change it, or you can again, if you want to do it properly, when you are taking the set square, don't turn. If you think that you can't take that measurement, you can again take this way. So you take this way on top of this ruler. Here, first keep on top of this and then drag it so that you get the line passes through B. Now you can draw the line. Now you can draw the line. That's the parallel line passes through B and D to AC line. So AC is the diagonal and these two lines are parallel and passes through B and D. Next one. Nima's birthday is 2002, 11/25. Find Nima's age in years, months and days on 2016, 8/20. So we can find out the difference. Year, month, date. 2016, 8/20. And subtract 2002, 11/25. So when you subtract, what you get? You can't subtract 25 from 20. So you take 30 from there. 30 minus 30 plus 20, 50. 50 minus 25. 25. Then you get 7 here. 7 you can't subtract this number from 7. So we take 1 here. That means 12. 12 plus 7, 19. 19 minus 11, you get 8 here. Then this becomes 2015. 15 minus 2, you get 13. So 13 years, 8 months and 25 days. We'll do the second part on next page. Write the time that has elapsed between 12/35 of 2015, January 1st and 19/20 of 2015, February 5th in days, hours and minutes. So you need all of these. So you need year, month, days, hours and minutes. So what's the date? 2015 and here this one first. 2015. Month 2. 5 days. And here 19/20. 19 hours, 20 minutes. And the next one, previous one is 12/35. 12/35 here and 2015, 1. So you need to find out the difference. Now, can we subtract 35 from 20? You can't. So you have to take 1 from here. 1 hour means 60 minutes. 60 plus 20, 80. 80 minus 35, you get 45 here. 45 minutes. Now here you get 18 hours. 18 minus 12, you get 6 hours. 5 minus 1, you get 4. Straight away you can subtract. 2 minus 1, that's 1. 15 and 15, 0. So what's the difference? What's the elapsed time? 1 month, 4 days, 6 hours, 6 hours and 45 minutes. I'll write in standard form. 6 hours and 45 minutes. So we completed all exercises in the revision exercise. So next time we'll meet you in the first lesson of the second term.